Thanks for being here for our last Class Connect of the school year. I can't believe it. It is coming to an end. So this is our last Class Connect. Next week is reserved just for you to take your semester finals if you haven't done so before that. And next week we will hold tutor times, but there will not be a Class Connect. Please remember that this Sunday, May 18th, is the deadline for all regular semester work. So everything that was assigned to you this semester, other than your semester final, Part 1 and Part 2, is due by this Sunday, May 18th. Okay? And also remember last week we discussed that if you submit your Part 2 test by this Sunday, May 18th, then you'll receive 5 extra credit points. Also, if you take the Part 1 test and you get an A on it and you would like your Part 2 test excused, just send us a K-mail and we will do that for you. Okay, so today what we're doing is we're reviewing just for the Part 2 test for your semester final in geometry. There are 4 questions. You choose 3 out of the 4 to do and submit, and it is worth 45 points. So again, if you submit this by this Sunday, May 18th, you'll receive 5 extra credit points. Or you have until Thursday, May 22nd to submit both parts of your final. Okay, so let us know if you guys have any questions about that. So all we're doing today is we are reviewing for your Part 2 test. We reviewed for your Part 1 final last week, so make sure you watch that recording if you haven't done so already. Great job, Jonathan. That's awesome. Now, again, if you get an A on the Part 1 test and you want your Part 2 test to count because you feel like it's going to help your grade that you'll do well on it, just, let us know that. Otherwise, send us a K-mail if you want your Part 2 excused. Okay, so let's talk about some of the questions that are going to be on your Part 2 final. Now, these are very, 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 very similar to what the questions are. Some numbers are, messed around with, so it's not exact questions, but so definitely, if you have your Part 2 final, you can print it out right now, actually, and look at some of the questions as we go over some of these. Mary, that is correct. If you get an A on your Part 1, you do not have to take Part 2, but just make sure you send a K-mail to us to let us know, to your teacher, let us know that you want Part 2 excused. Because some of you might still want to take the Part 2 test if it'll help you grade out more. Okay? Bye, John. Have a great summer. Okay, so bring us back to the beginning of this semester when we were talking about coming up with the equation for a plane. And the equation for a plane is in the form ax plus by plus cz equals d. So here they're giving you the equation for the plane. It's 2x plus 4y plus 2z equals 12. And Part A wants you to accurately sketch the plane on a set of axes showing all the calculations below. Now, to sketch the plane, what you have to do is you have to find the x, the y, and the z intercepts. So you need your x-intercept, your y-intercept, and your z-intercept. Does anyone remember how to find those using the equation that's given to us? So we have the equation, which is 2x plus 4y plus 2z equals 12. How would we find the x-intercept, the y-intercept, and the z-intercept? And those are the 3 points that we're going to plot to graph this plane. And it's very similar to if you were just looking at an equation. Let's say the equation is 2x plus 3y equals 12. Okay, here is just a linear equation. To find the x-intercept here, you would substitute 0 in for y. So our x-intercept would be 2x plus 3 times 0 equals 12, which is just 2x equals 12. So x equals 6, right? That's how we would find the x-intercept if it was a linear equation. Here we have our x, y, and z. So we're just throwing in the z-intercept in there. That's the only difference. So, yep, Madison and Pierce, what you guys wrote in the chat box, you're correct. So you substitute 0 into the other variables. So you plug, and Pierce, you wrote plug in 0 for x to find the x-intercept. Actually, it's the opposite. So you'd plug in 0 into y and z to find the x-intercept. Okay, yep. So any volunteer to do this one on the board? So to find the x-intercept, we're going to substitute 0 in for y and z and solve for x. To find the y-intercept, we substitute 0 in for x and z and solve for y. And to find the z-intercept, we substitute 0 in for x and y. Madison, thank you. Let me give you whiteboard privilege. You can go ahead. Great job, Madison. Yep, so that's the x, the y, and the z-intercept there. She substituted the zeros into the other variables to find the intercept that we're looking for. Okay, so Madison, can you graph it for us now? So you found your intercepts. So now all you have to do is plot the x-intercept, the y-intercept, the z-intercept, and then connect the three. Very good. So there's the x-intercept at 6. Good. The y-intercept is at 3. And the z-intercept is also going to be at 6. Perfect. And now you'll just connect those three. Great job, Madison. Thank you so much. Okay, so Madison graphed the plane for us. And what figure do we have? What shape is formed here, or figure do we have when we? So it's a triangle, but what three-dimensional figure can we see? If you look at, good, Laurel said a pyramid, right? So here, you got to visualize these parts also, right? And now we have a triangular pyramid. Good, so we have a triangular pyramid. So that's now what we're going to work on in the next part of this question. So the first part of your question is just accurately sketch the plane, showing all the calculations. So your calculations is showing the intercepts, how you find that, and then you would graph your intercepts and connect. And now we've created a triangular pyramid. So part B of this question is the three planes of the axes and the plane you have sketched create a triangular pyramid. Find the volume of this pyramid showing the formula you are using and all the calculations below. Okay, so to find volume of a pyramid, remember we have to use this formula. Volume equals 1/3 area of the base times the height. So area of our base is going to be area of a triangle because it's a triangular pyramid, so the base is a triangle. So here is, I want to just look at the base real quick. So here is our base. okay? And you're given all the dimensions of this triangle that you need to find area of the base, right? So you're going to find area of your base first over here. So you want to find area of this triangle, and you can see this triangle is 1, 2, 3 units here, and should be 6 units here. Let me move this. I think it should be right here, actually, this graph. 1, 2, 3, 4, 5. So actually should be right there, right? Let me just make sure that this drawing is correct. Okay, so we're 3 here. It should have been 6 on the z-axis. 1, 2, 3, 4, 5, 6. Okay, good. So we just needed to come to there on the z-axis, on the x-axis, I mean. Okay, so we have, if we're looking just at our base, we have 3 units here. We have 6 units here, and the height of our pyramid is also 6 units, right? So who can do the work on the board for this one? How do we find the volume? All right, Mark, awesome. I'm going to give you whiteboard privilege. So show us the area of the base, how we find it, and then the total volume. Mark, you should have it now. Thanks. Mark, remember over here, you're just finding area of your base, and for a triangle, it's not 1/3 base times, it's 1/2 base times height. So instead of having 1/3 here, you used to have the 1/2. Okay, good. Great job, Mark. Thank you so much for doing that one on the board for us. So the volume of this triangular pyramid is 18. And they're not giving us the units, but we just always make sure that you put cubic units for volume and area is always square units. Okay, so this is 18 cubic units for the volume of this triangular pyramid. Great job, Mark. Okay, so there is very similar to your question one you have on your final, your semester final. So part A, if you remember, was sketching the plane, showing your work, so finding the intercepts and then sketch the plane. And part B is finding the volume of the triangular pyramid that is formed after you sketch the plane. Okay, so on your part 2 test, you have a very similar question, not the exact one, but very similar. Okay. Let us know if you have any questions on this. Okay, let's look at another question. And we're comparing similar triangles, and we're going to come up with proportion. Well, first we're going to complete this proof. And then I believe part B is then creating proportions to find missing lengths. So let's see here. So if angle D is a right angle, so right angle, and lines PN, FG, and BD are parallel to each other, prove that triangle SPN, which is this small triangle right here, is similar to triangle SSG, which is the medium-sized one, is also similar to triangle SBD, which is the large triangle. Okay, so I'm going to highlight each of those triangles for us. So there's SPN. Okay, and then we have SFG. And then we have the large one, and I'm going to just draw it on the outside here, SVD. Okay. Okay, so one thing that they're giving us is that angle D is a right angle, right? And since we know that BD and FG and PN are all parallel to each other, what do we know about angle G and angle N, since they're parallel with BD? Okay, so that's a statement and a reason we could put in here. Right, Duncan. Good medicine. Right, they're all right angles. Okay, then there's an angle that they both share, that all three of them share, right here. This angle F is part of all three of the triangles, right? So using the reflexive property, we know that all angle S is congruent to angle S is congruent to angle S. Okay, anyone think they could fill in the statements and the reasons here? Yep, and Madison, you are correct. That is exactly how we're going to prove it. So any volunteer to fill in this proof here? And this last one, I'll just put in the last one right here. So the last step is going to be proving that those are similar to each other. So I'm going to put in angle D is a right angle. That's given to us. And in step one, I'm also going to put in that PN, FG, and BD are parallel. That's given to us. Okay, and then we can say, Duncan just wrote in the chat box that angle P, angle F, and angle B are congruent. They are congruent because we know that in similar triangles, all corresponding angles are congruent to each other. And also, if these lines are parallel, so this is also taking us back to Unit 1, is line BD and line FG and line PN are parallel to each other. And this line we can call the transversal. Do you remember what angle B, angle F, and angle P would be called? They're congruent to each other because of Y. And it's the same way why we can say angle D, angle G, and angle N are congruent to each other. Who remembers what type of angles those are called? Two parallel lines cut by a transversal. It's the angles that are in the exact same position with their parallel line and the transversal. Madison, awesome. Pierce, very good. Corresponding angles. Angle B, angle F, and angle P are congruent to each other because they're corresponding angles. Angle D, angle G, and angle N are also corresponding angles, and we know that they are all 90 degrees. Okay, so really, you could choose either one. So you can choose angle B, angle F, and angle P, or you can choose angles D, G, and N to say that they're congruent to each other. I'm going to go with Duncan had wrote before. I'm going to say that angle B is congruent to angle F, is congruent to angle P, and that's because they are corresponding angles. Or you could do angle D is congruent to angle G is congruent to angle N because they're corresponding angles. Okay, right, so these are all congruent to each other because they're corresponding angles. These are also congruent to each other because they're corresponding angles. And angle S is congruent in each of them because it's the same angle. And I'm going to say angle S is congruent to angle S is congruent to angle S because of the reflexive property. Or instead of that, you could have put, for the reason in angle 3, for the reason in statement 3, you could have just said angle D is congruent to angle G is congruent to angle N because they're corresponding angles and they all equal 90 degrees. So if either one's fine, you can just write corresponding angles. We'll know what you mean, corresponding angles theorem. The reflexive property is when something is congruent to itself. And now we have enough information, I saw some of you guys put in the chat box. It's the angle-angle similarity postulate. Right? If you find two corresponding angles that are congruent to each other, then we know that the triangles are similar. Yes, very good, Duncan. So high fives all around. Okay? And remember, you only have to do 3 out of the 4 questions. If you don't like proof, you don't want to do it, you know, that could be one that you might want to skip. Okay? So we know that they're all similar to each other now. So now in part B, angle D is a right angle and lines PN, FG, and BD are parallel to each other. A person who is 1.5 meters tall casts a shadow of 7.6 meters. Yes, Duncan, you're correct. So if you do all of them, you happen to get one of the questions wrong, hopefully you do the other one correct, so you can always do all 4 of them and see which ones you do the best on. Okay, so they're telling us that PN, which is the height of the man, is 1.5, or the person, is 1.5 meters. His shadow is 7.6 meters. His shadow goes from S to N. Okay. The distance along the ground from person N to the flagpole is 45 meters. Okay, so from N to G is 45 meters. And the distance from the flagpole G to the building D is 150 meters. Find the height of the flagpole FG. So here's what we're finding. And the height of the building BD. So I'm going to make that an X also. I'll make that X2. Here's X1, here's X2, because we've got to solve 2 different problems. Showing all calculations. Okay, so now this is where a lot of students make a mistake when they're setting up the proportions for these type of problems. Is they set up a proportion and they see, okay, well the man's height or the person's height and the height of the flagpole are in proportion to each other, and the shadows are in proportion to each other. And a lot of times the students think that the shadow of the flagpole is just 45 meters. That's where the mistake usually comes into play. Really, the shadow of the flagpole is from G to S, right? It's that total length right there. The shadow of the building is not just from G to D. The shadow of the building is from D to S. Okay, so that's where a lot of students make a mistake, is they don't add all the parts to get the shadow. Okay, yep, so you want to look at each triangle separately. So here could be the first part if we're trying to find FG. G to S is going to be the shadow, right? So the shadow is really 45 plus 7.6, so 52.6. So that's really the shadow. And we don't know the height. And we know this is 1.5 and this is 7.6. Okay, anyone want to solve these? Find the height of the building and the height of the shadow for us? I mean the height of the building and the height of the flagpole for us. Any volunteers? All right, Duncan, I'll give you whiteboard privilege. And Duncan, the one thing is just to make sure when you're doing the shadow, you're adding all the parts from G to S. Because it looks like on the when you set it up, you did 45 over 7.6, but it really should be the 52.6 over 7.6. I'm going to give you whiteboard privilege there. So your proportion, you just want to, instead of the 45 over 7.6, you should have the 52.6 over 7.6. Looks great so far, Duncan. So far he found the height of the flagpole, and that is the 10.38 meters. And now he's going to set up a proportion to find the height of the building. So there's a bunch of different proportions you can set up for this one. So this one, Duncan's using the largest triangle, triangle SBD, and the smallest triangle, SPN, to create this proportion, which is perfect. Yep, perfect. Okay, let's see how many of you guys get the correct answer. Type your answer in the chat box. Good, looks like a lot of you guys got the correct answer. And it could just be where you guys rounded, how many places you rounded to when you were figuring out your proportion and everything. So, but it looks like you're all right around the same. Right, so approximately 39.99 meters is the answer. Okay, great job, Duncan. Thank you so much for doing this one on the whiteboard. A round of applause for Duncan. So let us know if you guys have any questions. Now again, there were a bunch of different ways you could have set up the proportion. But the way that Duncan chose is correct. For the last part, he chose to use the biggest triangle and the smallest triangle. You could have chose to use the biggest triangle and the medium-sized triangle, triangle SFG, to set up your proportion. But either way, you're going to get the correct answer. Okay, no matter which way you do it, just as long as you set up your proportion correctly. Okay, so there is question 2. So again, part A was creating your proof as to why these three triangles are similar to each other, and we figured out it was the angle-angle similarity postulate. And then the second part was finding the height of the flagpole and then the height of the building by setting up the proportions. Okay. Okay. Here is question 3. Please review Unit 2, Lesson 2.15. Solids of revolution to help you figure out these type of problems. So given rectangles ABCD and PQRS, and given that rectangle ABCD is fully rotated about line BC. Okay, so here is rectangle ABCD, and here's line BC, and we are going to rotate rectangle ABCD about line BC. Okay. What figure is going to be formed when you take rectangle ABD and you rotate it? Good, Madison. Good, Duncan. Yes. Pierce, very good. A cylinder, right. And if you go to lesson 2.15, there's a really great visual showing you this. It's showing you the rectangle being rotated all the way around, and you see how the cylinder is formed. Okay? So this is the solids of revolution lesson. So you take a rectangle and you rotate it all the way around a straight line. You're going to get a cylinder. Okay, so a cylinder is being formed here. What is the radius of the cylinder that's formed? And what's the height of the cylinder that's formed from rectangle ABCD? So what's the radius? So we're taking it and we're rotating all the way around, right? Good, Madison. Good, Katie. Good, Mark. So the radius All right, so let me draw out the cylinder now. So draw it as best I can. Okay, so here is A to B, the 4.2, right? And here was, if you can think, B to C, right? Which is the same as this height right here, which is the 5.4, right? So the radius is the 4.2, and the height is 5.4. Okay, so when we rotate the rectangle about line BC, we get a cylinder. Okay, and about which line could you rotate rectangle PQRS? So now looking at PQRS, what line would we be able to rotate PQRS about to get a similar solid? Good, so a bunch of you guys are saying SR or, so we could rotate it about SR right here or PQ, right? Because if we look at it like this, if I just draw it up like that, then it's the same direction that ABCD is going. So here is P, S, Q, and R. And here's the 3.1. Good, and here's a 1.9. Very good. So you guys are writing in the chat box. This one, we would have to rotate about PQ or SR, and we would get a cylinder that's similar to the cylinder that we get when we rotate ABCD. And in this one, the radius would be 1.9, and the height would be 3.1. Right? Okay, good. Okay, so we get a cylinder, and then we can figure out our radius and height. We want to figure out the radius and height because the next question, what are the ratios of the surface area and volumes of the solids generated from ABCD and PQRS? Okay, so we know it's cylinders. We'll just draw out the two cylinders. I'm going to draw out the height and the radius for each of them. Okay, so what are the ratio of the surface areas and volumes of the solids generated from ABCD and PQRS? Any volunteer to do surface area and a volunteer to do volume? All right, Duncan, I think you still have, let me give you whiteboard privilege. Okay. So actually, all right, Duncan, you want to do volume? Okay, so Duncan, let me give you whiteboard privilege, and you can do volume. And anyone want to do the surface area? Katie, let me give you whiteboard privilege. Okay, go ahead. Okay, so right now, Duncan is doing the volume formulas to find the volume, and you certainly can do this. Find the volume and then compare the two volumes to figure out the ratio. This is the long way to do it, but if you guys remember back in Unit 3 when you learned about ratio of areas and ratio of volumes, and if you find the scale factor, you can find the ratio of the areas and the ratio of the volumes by just setting up the ratio. Let me do this on the top here. So T equals scale factor, T squared is the ratio of the areas, and T cubed is the ratio of the volumes. So if you know your scale factor, then you can just square that to find the ratio of your areas, or you can cube that to find the ratio of your volumes. And I can tell you the one on your final, the numbers are a lot easier for you to see the scale factor to figure this out. This one, actually these numbers don't look, they're not as easy as what is actually going to be on your final. So Madison wrote, could you just square the numbers like 1.9 and 4.2 and put them in a fraction for the ratio? First, you've got to, so if you're looking at the ratio of the radii, or you can do the ratio of the heights. So 4.2 over 1.9, or 5.4 over 3.1. But for this one, actually, I don't think these numbers are good what's given to us here, because the height, these heights should be in proportion, the same ratio as these radii, and they're not. So there's actually a mistake with this question that I see here, because we do, here, let's see, if we do 4.2 divided by 1.9, so this is what Madison's asking. So this is, instead of going through the whole process of finding the actual volumes and surface areas, because you don't have to do that, the ratio 4.2 over 1.9 is approximately 2.2. Okay, but then the ratio of 5.4 over 3.1, which should also be in the same proportion, is 1.74. So there's actually a mistake with this problem here. They should be the same. They should be in the same proportion, right, Mrs. Williams? I'm not. Am I making a mistake here, or am I seeing this correctly, that there is a mistake with these numbers? Because on your problem, on your test, you're going to have, you're going to be able to find the ratios, and you're going to see that the ratios of your radii is the same ratio of the heights of your cylinder. Okay, so for these, there's an issue with these numbers here. So, which is not your fault, my fault. So I'm going to see if I could, instead of, so I don't want you guys to keep doing the work of finding surface area and volume, because on your test you don't even have to do that. You're just going to use the ratio formulas. So let me make it a little bit easier for you guys to see here. And 1 second, let me just create 2 new cylinders. Okay, sorry about that, guys. And I'm going to say that this is, nope, Katie, don't worry, don't finish, and Duncan, don't finish. I want to change these because you guys don't actually have to do all the work that you're doing. I just want you to use the ratio formulas. Okay, I'm just going to change these so that it's easier to see. Okay, so let's say we have 2 cylinders now. The radius here is 3, is 9. The radius here is 3. Okay, the height here, let's say, is 18, and the height here is 6. Okay, this is going to be a lot easier to see now. Okay, so you guys were doing great showing us the formulas for volume and surface area and doing all that work, but you don't have to do it. This is going to be a lot easier way to solve this problem. Okay, so let me just get rid of this work here. Okay. All right, so here are our 2 new cylinders. Okay, let's not look at these anymore because these numbers are off. Okay, so here's our 2 new cylinders. We have the radii are 9 and 3, and the heights are 18 and 6. Okay, first thing you're going to do to find the ratio of the surface areas and the ratio of the volumes is you want to find your scale factor. So our scale factor here is, if I could do either look at comparing the radii or I can compare the heights. Doesn't matter. I'm going to compare the heights. So 18 to 6, which equals 3. So my scale factor is 3, right? Now, to find the ratio of the surface areas, all you have to do is follow right here. T squared is the ratio of your surface areas. Okay, so if T equals 3, then T squared equals 3 squared, right? So the ratio of the surface areas is, so right here we're saying it's 3 to 1 for the scale factor. So the ratio of the surface areas is going to be 9 to 1. Okay, and then if we look at the ratio of the volumes, we're doing right here is T cubed. Okay, so if T is 3, then T cubed is going to be 27. So the ratio is 27 over 1, 27 to 1. Does that make sense? Do you guys see that? So I'm sorry, it took me a while to look at that problem to figure out that all those numbers were not correct there for the ratios. So you don't even have to find surface area, you don't have to find volume. All you have to do is remember these ratio formulas. Is that if you find the scale factor, your scale factor squared is the ratio of your areas. The scale factor cubed is the ratio of your volumes. Okay, so the answer here would be that the ratio of the volumes is 27 to 1, and the ratio of the surface areas, T squared, is 9 to 1. And if you actually were going to take the time, like Katie and Duncan were doing, to find the volume of each of these and then divide those volumes out, you're going to get that ratio. Or if you find the surface area of each of these and then divide those surface areas out, you're going to get this ratio. So you can go to all that trouble and do that, and it's great practice to help you remember volume and surface area to find those. But for this question, you don't even have to do that. You just have to remember the ratios. Okay? So sorry, guys, that was my bad. Those numbers were off. On your test, it's going to be a lot easier. You can be able to see the scale factor a lot quicker. It's not going to be decimals. Your scale factor is not going to be a decimal. It's going to be a whole number. Okay? All right. I just want to look at question 4 real quick. This part of question 3, you're going to see part D. It's going to ask you about golden rectangles. Golden rectangles have a ratio of 1.6. So if these rectangles have a ratio of 1.6, then it is a golden rectangle. But you guys skipped this lesson. Okay? You skipped this lesson. So don't even worry about it. We will excuse that part on the final. Part D of this question, so don't even worry about it. If you want to answer it, go right ahead. If you answer it and you get it wrong, we will we'll excuse that part since we did skip that lesson this year. But just know that the golden ratio is approximately 1.6. So if you find the ratio of the sides to be 1.6, then it is a golden rectangle. Okay, so that's what that is. We have 2 minutes. I just want to look at question 4 real quick. So the diameter of a circle is 12 centimeters. So the diameter from B to D is 12. Okay. Chord AD is the same length as the radius. Well, if we know that the diameter is 12, that means the radius is 6, which means AD is 6. Okay. Use the information, the diagram, your experience in geometry from this semester to answer these questions. Okay. These are all from your Part 2 test in geometry for the semester final. Okay. Who remembers the right triangle? A right triangle where your radius is twice the size of your smaller side. Does anybody remember this special right triangle, the dimensions? It's not 45, 45, 90. That is a special right triangle, but that's not the relationship of the sides. 30, 60, 90, right? A 30, 60, 90, where the side directly opposite the 30-degree angle is your smallest side. And then the hypotenuse is twice that, remember that? So this right here is a 30, 60, 90 triangle. So just keep that in mind. Okay, so when they're asking you to find the cosine of angle DBA, that's this angle right here, we know that this is the 30-degree angle, this is the 60-degree angle, and this is the right angle, because this is a 30, 60, 90. Okay? So just keep that in mind for question 4, that that triangle in there is a 30, 60, 90 triangle, because they said they gave us the sides, and we know that the hypotenuse is twice the side, twice the length of the side that's directly opposite the 30-degree angle. Okay? Remember, cosine is the adjacent over the hypotenuse. Sine is the opposite over the hypotenuse. When you get to this problem, you're going to be using some of those trig ratios. Okay? You're going to have to use arc length formula in this one, I believe, also. Remember, arc length is your central angle over 360 times the circumference, 2 times pi times the radius. So remember that. There's going to be part. Remember the formula, the theorem, that if you have two chords that are congruent to each other, then the intersected arcs are also congruent to each other. Remember that. That's going to come into play with this question as well. Okay, sorry guys that we didn't get a